Chapter 5.7, Differential Equations. Day 1, Verifying Solutions. A differential equation, remember that is an equation that's a derivative. And to solve a differential equations, you're usually going to take the antiderivative. We're going to take a step back. We're going to talk about verifying that you have the correct solution. All right? Like verifying that you have a correct solution for algebraic functions, it's the same thing. You're going to plug your answer in and see if it works out. So here's our, right here is our differential equation. And here we have what we're proposing to be a solution. And we're going to start by verifying that's a solution. We're going to do that by plugging it in. So first off, what we have here is the second derivative. So we need to plug the second derivative in. So our first derivative would be cosine of x. Our second derivative would be negative sine of x. And now let's plug that in and verify that this is in fact a solution. Our equation says the second derivative, negative sine of x, minus the first derivative, sine of x, equals 0. If I simplify that, I get negative 2 sine of x equals 0. And we can see that this is not a solution because it does not work out as an identity. So in this case, when it asks, determine whether or not the given function is a solution, because it did not work out, we say no, not a solution. All right, let's try that again with another problem. All right, so our next equation is y equals ce to the x. All right, and so then we're going to need, again, to plug and chug, we need to plug it into the differential. First thing we need to plug in is the second derivative. Well, our first derivative is ce to the x. Constant rule, and it's e to the x. Our second derivative is also ce to the x. And as we plug those in, we got ce to the x minus ce to the x equals 0, which is what we're supposed to have. So yes, this is a solution. Because when we plugged it in, just like we did for an algebra problem, we plugged it in, it worked out to what it was supposed to work out to be. All right, let's try another one. All right, let's say this differential equation is x y prime minus 3y equals 0. Verify that y equals cx cubed is a solution. And find the particular solution determined by the initial condition. So what's happening here is we have a solution. This is called a general solution because it doesn't have the constant figured out. We don't have the constant figured out, so it's a general solution. Once you get the general solution, you're going to use some initial conditions to get your particular solution. All right? So first off, we need to verify that this is a general solution by plugging it in. Well, first off, y prime equals 3cx squared using the power rule. So now we can plug that in. X times 3cx squared minus 3 times y, which is cx cubed, should equal 0. As we simplify this, x times x squared is x cubed. So we got 3cx cubed minus 3cx cubed equals 0. So that is a solution because it works out as an identity. All right, and the next thing we're going to do is we're going to find the particular solution by plugging in the points. All right. So the initial condition, y equals 2 and x equals negative 3. So take that and put it into our general solution. and solve. 2 equals c times negative 3 cubed. Negative 3 cubed is negative 27, so c equals 2 over negative 27. So our particular solution, now that we know c, is y equals negative 2/27 x cubed. All right? So that, in a nutshell, is the differential equation. Separation of variables to solve this. All right? Right now, we're just showing what you do when you have a solution. You need to check it out. So in review, how do you tell if a function is a solution to a differential equation? Take the derivative, or you may need to take a second derivative. We had to do that a couple times. That's not the limit. You may have to go to third derivative, fourth derivative. Then once you have that, plug and chug, simplify, and it should equal the expression that they're giving you.